Okay, let's take a look at this one. Now to find the derivative, I'm going to use the quotient rule again. So this will be P, this will be Q. Quotient rule because we've got something on the top divided by something on the bottom. P prime, the derivative of x squared is 2x. Q prime, the derivative of x squared is 2x, and the 5 drops away. And our formula is P prime Q minus P Q prime over Q squared. So we'll plug in everything. P prime is 2x times Q, which is x squared plus 5, minus P, which is x squared, times Q prime, which is 2x, over Q squared, which is x plus 5 squared. Let me double check everything. 2x times that, and then 2x times, okay. Now I could get rid of parentheses, but I could also factor out a 2x. Because if I look at my groups, these right here, they both have a 2x in common. So I factor out 2x, and that leaves me x squared plus 5 there, minus x squared, over x squared plus 5 squared. X squared minus x squared drops away. 5 times 2 gives me 10x, over x squared plus 5 squared. Now to find the critical values, we're going to set top equal to 0. So we got 10x equals 0. And we'll set the bottom equal to 0. X squared plus 5 squared equals 0. Now here I'll divide both sides by 10. And you get x equals 0. On this one, if you got parentheses to a power equals 0, you can drop the power. So we got x squared plus 5 equal to 0. Take the 5 over, it becomes a negative 5. Drop our squared, put a plus or minus square root around the other side. And the negative inside of a square root is going to give us an I, so we drop that part. And our only critical value is 0. So I'm going to build a table of intervals. Clear over here is negative infinity, clear over here is positive infinity. We want to choose test cases. Something between negative infinity and 0, like negative 1. Something greater than 0, like 1 or 2 or something. Now we want to plug those into our derivative. The bottom part is squared, which means it's already always positive, so I don't need to worry about the denominator at all. If I plug this x value into the top, though, I got 10 times negative 1, which is negative. Negative divided by positive is negative. If I plug 1 in, 10 times 1 is 10, which is positive. And positive divided by positive is positive. So this is, it's negative here, so this is decreasing. This is positive, so it's increasing. So it's decreasing from negative infinity to 0, and it's increasing from 0 to positive infinity. Now our relative min, relative max, assuming it exists, is where the changes from increasing, decreasing, or vice versa. This is decreasing, changes to increasing, so this would be a min. So we got a relative min at 0, comma, and then you want to plug 0 back in your original function. I'd have 0 squared over 0 squared plus 5. 0 squared is 0, divided by 5 would give us 0. Okay. Now, let's see, the vertical asymptote. Vertical asymptote, you go back to your original function. You factor the top, factor the bottom. There's nothing to factor. You cancel. You can't cancel anything. Then you set your denominator to equal 0. But if I do that, I'm going to get the same thing as I did right over here. I'm going to end up with an I. And you can't have I's for your vertical asymptote, so there's none. Now for our horizontal asymptote, the degree of the top, degree is the largest power of x, is 2. Degree of the bottom is 2. When the degrees are the same, your horizontal asymptote, you create a fraction out of the number that's in front of the x, the largest power. So this will be 1 over 1. The number in front of this x squared is a 1. Number in front of this x squared is a 1, which would give us y is equal to 1. Now, for graphing purposes, I won't do that part, but you just plug in your calculator. You put parentheses around top, parentheses around the bottom. In this particular problem, you wouldn't need the parentheses around the top. It'd still give you the same graph. But it's always a good idea when you deal with rational functions, put parentheses around top, parentheses around the bottom.